let's work through a typical exam-style question on arcs and sectors. And that's the question we see here, for which we're told the length of the arc AB is equal to 4 pi centimeters, so that's this arc length here, and we're also told that the area of the sector OAB is k square centimeters. So that's the shaded area we have here, which is equal to k square centimeters. Finally, we're told find the value of k. Okay, well first of all, let me point out that this question seems to involve two things we need to know. Those being the arc length of a circular sector as well as the area of a circular sector. And when we're told to find the value of k, since we're told that the area of the sector OAB is k square centimeters, in essence, what we really need to find here is this sector's area. Now what I'll start by doing here is to remind us of the formula for an arc length as well as the formula for the area of a sector. And I'll do that in the upper right hand corner here. But before doing that, let me give the angle that's formed by this arc a name. So that would be this angle here, and I'll go ahead and call that angle theta. Okay, now that I've done that, this arc length, which I'll just call L, is given by the following formula. L is equal to theta divided by 360 times 2 pi r. There we go. That's the formula for the arc length of a circular sector. And I'll just write arc length on the side here. Arc length. Next, the formula for the area of this circular sector, which I'll call capital A, is equal to theta over 360 times pi r squared. And I'll go ahead and box it as well, and I'll label it area, like so. Okay, now just to be clear, in both of these formula, the theta that we have is the angle that's formed at the center here, and the r that we have is the radius of the circular sector, which in this case will equal to 12 centimeters. Now, to find the value of k, since k is equal to the area of this sector, we can start by copying the formula we have for the area, but we'll replace the a on the left-hand side by k. That's what we're trying to find. In other words, we can rewrite that formula as k equals to theta over 360 times pi r squared. Now, replacing r by the radius we have here, which is 12, this turns into k equals to theta over 360 times pi times 12 squared. And at this stage, we realize one thing. We're unable to calculate what k is here because we don't know what the angle theta is. In other words, this expression has two unknowns. The first of which is k, which is the unknown we're trying to find, and the second unknown we have here is this angle theta. And so that tells us that the next thing we need to do here is figure out what this angle is. And for that, we turn to the other bit of information we were given in the question. And for this case, that other bit of information which is going to help us find what theta is the fact that we were told that the length of the arc AB is equal to 4 pi centimeters. In other words, this length here equals to 4 pi. So copying the formula we have for the arc length, but replacing the left-hand side L by 4 pi, it turns into 4 pi equals to theta over 360 times 2 pi r. Now replacing the r that we have here by the 12 centimeter radius, this becomes 4 pi equals to theta over 360 times 2 times pi times 12. And looking at this equation, we realize that it only has one unknown, that being the angle we're trying to find, theta. And so all we have to do now to find theta is tidy all of this up a bit and make theta the subject. So let's do that. One thing I notice when looking at this is that both sides of this equation are being multiplied by pi. In other words, the left-hand side and the right-hand side have a common factor of pi. And consequently, we can just cross those pi's out. And so this becomes 4 equals to theta over 360 times 2 times 12, which is 24. So I'll just write 24 here. Now, remembering that our goal here is to figure out what theta is, we need to get rid of this 360, which is dividing the right-hand side. And so for that, I'll multiply both sides of this equation by 360, so that the left-hand side becomes 4 times 360, which you can go ahead and check is 1,440. And on the right-hand side, well, we have theta divided by 360 times 360, which makes these 360s disappear, and we'll just be left with theta times 24. And so we have theta times 24. Finally, I want to get rid of this 24, which is multiplying theta, and for that, I'll divide the right-hand side by 24, and I therefore do the same on the left-hand side. And so I'll carry on with my working right here. We can go ahead and state that 1,440 divided by 24 is equal to theta. And by all means check, but 1,440 divided by 24 is equal to 60. And so we can state that the angle theta is equal to 60 degrees. Done. We now have the angle theta we needed to be able to find the value of k. And so going back to the formula we have for k here, but replacing this theta by 60, it turns into k is equal to 60 over 360 times pi times 12 squared. And now to calculate this, I turn over to my calculator, which you can see here, and I enter the expression to evaluate. So that's 60 over 360, and I write that inside a pair of parentheses. I'll type 60 divided by 360, I close the parentheses, times pi, and on this calculator there's a special button for pi right here. There we go. Times 12 squared, or 12 raised to the power of 2. There we go. I'm happy with all that, and I click on Enter. And we're done. Copying what I see on the calculator, I can state that k is equal to 75.3982, or rounding to 3 significant figures, that would be k, which equals to 75.4. And that's the final answer. And there we go. That's it for this exam style question on sectors and areas.